Hello guys, welcome to PlaySport 2 Edu and my name is Vinay Kumar Nainabatani. Today we are going to learn nodal analysis and that too without Supernode. So let's get started. Before going to learn nodal analysis, let us see what is nodal analysis exactly is. Nodal analysis is we will find the voltages of nodes in the given circuit. Okay. So whatever circuit is given, if we want the nodal voltages, then we will use nodal analysis. For that, I am going to give you step-by-step procedure. For any given circuit, you can use those steps and find the nodal voltages. Step 1. The first step is you need to count the number of nodes. Okay, how many nodes are there in the circuit? So let's count in this circuit. As I already told that in my previous network classes, this whole thing is one node. So I'm naming it as 0 and this is one node and this is one node. So total 3 nodes are there. Okay. In that, I am going to consider any one of them as reference node. So I am considering this as reference node for easiness. Actually, you can also consider 1 as reference node, 2 as reference node, whatever it is, whichever node you want to be taken as reference node, you can take it. I am taking 0 node as reference node. Okay, we have 3 nodes. In that, I assigned 1 as reference, so the nodes left is 2 nodes. This number 2 has a significance that we will have 2 nodal equations. Understood? So whatever may be the number of nodes minus 1 gives us number of nodal equations in nodal analysis. That's the step 1. Coming to the step 2. Step 2 is assumptions. What are the assumptions you have to take? Keep in mind that assumptions are not that they should be possible. That means whatever you are taking as assumption, it may correct or wrong. Okay, it will be correct or wrong. So we are taking assumptions to go to the next level of analysis. So what are these assumptions is, I am considering voltage at node 1, that is V1, is greater than voltage at node 2, that is V2. Okay, that voltage and this voltage, I am giving the relation actually, inequality, that is V1 is greater than V2. So why I am giving the relation like that? Because I want to know the direction of current flow in node 1, from node 1 to node 2. If V1 is greater than V2, the direction of current will be from 1 to node 2. If V2 is greater than V1, then the direction of current will be from 2 to 1. Understood? In order to get the direction, I gave the relationship. And another assumption is V1 is greater than 0 and V2 is greater than 0. Because I want flow of current from 1 to 0. Understood? This is V0 actually. I am considering I grounded the reference node, so I can write it as 0. So V1 should be greater than 0, V2 should be greater than 0. These are the assumptions that you have to keep in mind. These are the assumptions because they will be correct or not, but they will let us to do analysis easily. Now I am going to give you the directions at node 1. The current 1 ampere is flowing into the node and V1, this is V1 and this is V2. So V1 is greater than O, so the current will be from V1 to O, that is 0, and V1 to V2 will be the current. Step 3, and the same way I can write for the node 2 like this. Okay. Step 3. Step 3 is nothing but writing the Kcl equations. Kcl. You know Kirchhoff's current law, right? Kirchhoff's current law is nothing but if you consider a node and there are many currents into the node and coming outside the node. Let it be I1 and I2, I3, I4. So the sum of currents entering into the node. Sum of currents entering into the node. What are the currents entering into the node? Those are I1 plus I2, right? Is equal to the sum of currents leaving the node. Here I3 and I4 are leaving. So I3 plus I4. This is KCL. So KCL will be purely depending upon the node. So we will have two equations because we have two nodes other than the reference node. Now KCL equation at node number 1. KCL at node number 1. I am drawing it. See here. We have 1 ampere here. Here R is there and this R is 2 ohms. Here 6 ohms is there. This is node V1, V2. Okay, this is the circuit. I took a part of circuit. Okay. Now the current equations, KCL equations, let this one be I1, I2, I3. So according to KCL, I1 is equals to I2 plus I3 because I1 is the current entering the node and I2 and I3 are the current leaving the node. So 1 is equals to, that is I1 is equals to V1 by R. Here R is 2 plus V1 minus V2 by R, that is 6. If you have any doubt how I wrote this, see here. If there is a resistor with V1, V2 voltages across it, then the current, if V1 is greater than V2, then current will flow from 1 to 2. Okay, current will flow from 1 to 2, and the current is V1 minus V2 by R. Understood? And if V2 is greater than V1, then the current will be V2 minus V1 by R. Understood? In this way I wrote this equation. Now simplifying this equation gives me, I have to take the LCM. Here it is 6. 6 is equals to 3V1 plus V1 minus V2. Therefore the equation, first nodal equation is 4V1 minus V2 is equals to 6. We got the first nodal equation by considering the first node. Okay, this is the first nodal equation. Now coming to the KCL at node 2. We have a node 2 like this. It is 6 ohms. This is node 1. So this is I and this is 7 ohms and this one is, I have to see this, 4 amps. Okay, so now the currents are flowing like this. So let this be, I have already given the name for this. This is I3. So let this be I4 and I5. So I3 is equals to I4 plus I5. I3 is nothing but V1 minus V2 by 6 and I4 is 4 amps plus I5 is V2 by 7. And again taking LCM, I am sending 6 that side. V1 minus V2 is equals to 6 into 4 plus 6 into V2 by 7. Understood? Now taking 7 here, this side, 7 V1 minus 7 V2 and 6 fours 24 and 24 sevens, 24 sevens and 4 28 to 168, right? 168 plus 6 V2. Therefore 7 V2 minus 7 V1 minus 13 V2 is equals to 168. This is our second equation. Okay, this is our second KCL equation. So we got two equations, right? So we have to simplify the 1 and 2. That is our step 4. What is a step 4 is simplify or solve the nodal equations. Okay, that is what you have to do. How to solve or simplify the equations? I think we got 4v1 minus v2 is equals to 6 and 7v1 minus 13v2 is equals to 168. For solving this, we have two ways, actually using the Cramer's rule and the substitution method. Okay, in Cramer's rule, if the equations are very high, like number is very like more than 3 equations, Cramer's rule will serve as a lot. But for 2 equations, substitution method will be more than sufficient. So I am using substitution method here. Okay, if you want Cramer's rule, comment below. I will again do the video on that. So considering these equations, see here we have 13 here. If I multiply 13 for the equation 1, I can easily subtract, I can easily eliminate v2 such that I will be left with v1. So what I do is I will multiply 13 with the first equation, and what I do is I will subtract it, I will subtract the second equation from it. So what is that? Minus 7v1 minus into minus plus 3v2 and 168. Okay, now this will be transformed into 13 fourths is 52, right? So 52v1 minus 13v2 and 13/6 is 78, I think. Yeah, 78. And minus 7v1 plus 13v2 and 168. I have already subtracted here, so the signs are changed. Now I can directly add them. So after adding them, these two will be eliminated. So I will be left with 45v1 45v1, I am writing here. I will be left with 45v1. Here, see here, I forgot to say this. After multiplying with minus, this will also become minus. So I have to write here. So 45, here also minus will be there. So the 45 is left with minus 90. 45 to. Therefore, v1 is minus 2. Okay. See here, I told you an assumption that v1 is greater than 0, but we got v1 is equals to minus 2v. Assumption is wrong doesn't imply our procedure is wrong. We just assumed that v1 is greater than 0, but we got v1 is minus 2v. So even though we are doing false assumptions, we are getting the correct answer. That you should remember in mind, because some of the people may think like that if we take the wrong direction of current, we may end with wrong answer. It's not the thing, because if you take wrong direction, you will get v1 as minus, like if i1 you take something from 1 to 2, if it is wrong, you will get i1 as negative number. That's the important thing. Okay, no problem, even the assumptions are wrong in this method, you can continue. And what is v2? For v2, I will substitute v1 in this equation 1. So 4 into minus 2 minus v2 is equals to 6. Minus 4 into minus 2 is minus 8, minus v2 equals to 6. Therefore, v2 is equals to minus 14 volts. See here, even the second one is also, second assumption also is wrong. That is v2 is equals to minus 14 volts. Understood? So in this way, we can find the node voltages using the nodal analysis.
Hope you guys enjoyed this video. So please like, share, comment and subscribe. If you guys didn't like this video, please let me know through comments. Thank you.